Hello everyone and welcome to another session of our Digital Days. My name is Larissa and I will moderate this session today. We are very pleased that you took the time to participate in our webinar today. The topic of today's session is Tuning DRF, Learn About Impedance Dynamics, and the speaker is Chang, who is working at Würth Elektronik eiSos. Before we start the webinar, I would like to give you some more information. First of all, you will be muted during the whole session, so you won't be able to ask questions via the microphone. But you can just put them in the chat and Jason will answer them after the presentation. Today's webinar will be about 20 minutes long, and after that we scheduled another 10 to 15 minutes for the Q&A session. If we are unable to answer all the questions within this time, we will just answer them via email in the next few days. And last information from my side, you will receive the link to the recording and the presentation in the next few days via email. So enough from my side. I will now hand over to Jason and wish you an exciting webinar.
Hello everyone, this is Jason. I am one of the course PM in Würth Elektronik. Welcome to my session. Today the topic is Tuning the RF, Mastering Impedance Dynamics. Welcome. Okay, let's go to the agenda. The first half of this presentation, I will speak about the problems you will face when you are doing a PCB transmission line design. Also, the designing the connector. Also, the problems you might have when you are using our N-launch connector, THT connector, or SMT connectors. At the second half of this presentation, I will give you some guidelines, the hints you can think about when you are trying to make or try to get a good impedance matching result when you are working on either the transmission line on PCB or the designing the connector. Also, when you are using our course connector in general, the PCB connectors. Okay, let's begin. Let's start from why is impedance matching important? With a good impedance matching, you can get maximum power transfer, minimization of signal reflections, reduction of crosstalk. These two, I believe, is very important for coax connectors in general. And the fourth one is minimization of energy loss. Okay, these are the good advantage you can get from good impedance matching. In general, the coax standard is using the 15 ohm. If you are going to lowest attenuation with coax, then the product you can select it's 75 ohm. If power handling is what you are going after, then it is 30 ohm. Okay. Look into the trace line. When this is a result that we get from our experience with the simulation software, also develop of the product. When the signal comes from the connector, which is to the trace with good impedance, the good 15 ohm trace line, the impedance, you get a good result of 15. But when the trace line got bigger and wider, in general, the impedance tend to get lower. If the trace line is back to ideal 50, it comes back for sure. But if the trace line got thinner, so the impedance tends to get higher. Okay, there is very complicated math and series to support this situation or this graph here, but we will not go that far today. Simply keep in mind what will happen if the trace got bigger and the trace got thinner, it will help you to go through the presentation with me here today. So speak about the transmission line on PCB. In general, there are two types of transmission line we use commonly. The first one is the CPWG, and the second one is microstrip line. There is some difference with these two designs. Beside the structure you can see from the big pictures here, the CPWG is mainly for extend the transmission line from connector to signal source. And for microstrip line, it's a connection from the connector to antenna or to the test board. You can really see the CPWG that is applied or designed for antenna on the daily uses. Okay, so let's move on to the problems when you can have when you are trying to do the impedance matching. Let's start from the trace line on PCB. If you are designing a straight trace line, you can get a smooth impedance easily or easier compared to a right angle line. Okay, so you can see that without a good tuning, if you just give it a right angle here on the PCB trace line, the impedance tends to get low. The basic reason behind this is that the path changes when it is turning the right angle, and this turning causes the discontinuity. The discontinuity will give you reflections onto the signal, and reflections is not what we wanted. So the reflection gives you higher energy loss. This is the main issue if you don't tune the main problem if you don't tune the trace line well when you are designing your trace line. Okay, let's look into the connectors. The connector is similar situation to the PCB trace line. Inside the connector, if it's well straight, then you can it's easier for you to get a smooth impedance when you are designing the connector. But if you simply build a right angle connector without checking in detail, the same issue happens. The turning path gets the impedance lower, then your connectors would not have a good impedance matching result at all. Now you know about the connectors. Let's look at the different type of connectors. For start with the end notch, you can see that when the signal comes from interface passed through the body, here it's still quite okay, but there is a big drop. The area turns out to be the contact area for the pin to the pad. It's mainly due to the size and the area increases at this section. If you are trying to use an end notch connector, right, if you just place the connector to the PCB directly, this area will be the problems you need to consider. Okay, so far so good. Hopefully for everyone. And let's look at the THT connectors. The THT connectors have more problems you can think of, I guess. The first is the gap between the connector and PCB. And the second is the angular propagate direction. The signal propagate wave changes. Third is the extent connector center contact. Okay. And the fourth is the gap between the center contact pad and the ground. These 4 points together, without tuning, if you simply place a THT connector directly to your PCB, then you will have a lower impedance result. That is not ideal. Okay, Let's move on to the THT connector type. The SMT connector type. For SMT connector type, take a time to think about it. What could be the problems? Okay? Yes, it also has the problem of gap between the connector and the PCB and the angular propagate direction, same as the THT. And the third one and the fourth one is related to the pad dimension and the gap between the center contact, pad, and ground. If you directly place a SMT connector to your PCB or onto your PCB without tuning it, you will also get a lower impedance result after all. Alright, before we move to the next pages, let's do a small summary of the factors that will influence the impedance. First is the angular traces, either it's on the PCB or inside a connector. Second one is the center contact part area, that when the center pin touches the PCB, this is something you need to focus when the problem can occur. And the third one is the angular signal propagation. There we have the extend center contact, the gap between the connector and the PCB. And the last one is the gap between the pad and the ground, or even the shape of the pad. Okay, now I have mentioned the problem when you are doing the impedance matching. While you are listening, after here, you might already have done some thinking inside your brain or inside your mind. Now it's time for me to give you some directions and hint to solve the issues. Okay, let's begin. Let's start from the PCB trace line, the right angle line. What you can do first is you can give it an arc shape, a smooth turning point. It's like when you are driving on the road, you don't want to turn a road like directly 90 degrees. It's the same thing for a signal path. Giving it an arc shape will help. It's helpful on your impedance matching. And the second thing you can do is try to change the path at the front and also at the back of the arc shape. Imagine that when you are driving on the highway and your car is the signal that you're trying to go through pretty fast. When your lane is 2 lane and it expands to 4 lane, you don't want the road to suddenly expand from 2 to 4, right? This is exactly the same thing for signal paths. On the opposite, when you are on the 4 lane road and the road will change to 2 lane at the front, you don't want it comes in all of a sudden. It's the same thing for coax signal. You want to make sure the road is smooth and can go at the speed. The speed is about the same all the way down from the beginning all the way to the end. And the third option, what you can do is you can try to adjust the gap distance. Okay? So by balancing the 3 points above with our simulation result, before tuning, the impedance drops low. And by giving an arc shape and adjusting the distance and the gap, and also the front and the back of a trace line, you can get a much better smooth 15-point result. Okay? It happens very similar to the inside of connector, but different. For an inside of connector, of course, you want to keep the trace line smooth and straight. But for a designer of connector, what can they do to tune the connector? The first thing they can consider is that by adjusting the inside structure, for example, giving it in a notch, this small gap here, and also he can kind of balances and adjust the ratio of the air part, the air value, and also the insulation dimension inside of connector. It's a balancing game for him. And the fourth one you can do is also to change the outer contact into dimension as a designer. By balancing this method, you can get a well-tuned right angle connector. So the designer would need to spend a lot of time and effort try to make sure the connector he designed is a good, well meshed. But don't worry, the right angle connectors from our catalog in our warehouses is all already well tuned. So when you received our right angle connectors, don't worry about it. It's already done from. Okay. Let's speak about each connector type in detail. First, let's start with the N-notch. Well, for N-notch connector, what you can do when you are holding a connector and you have the PCB, it does not match. What you can do is, try to check the center pin structure. There is a lot of selections. Either it's a round post, it's a flat tap, or different shapes. And also, what you can do is tune the center contact layout dimension. This picture here you can see closely with the mouse is that we already make the trace from wide and comes a little bit thinner slowly with a distance. This is something you can consider that would be helpful to get you a better matching result. And for the third one, is trying to adjust the gap dimension, which is the width. And the contact, mainly it's on the contact area. So with these three methods, it will be helpful for you to get a smooth impedance tuning result like ours. The example here I showed in this presentation is a round post. If you directly put a round post to a PCB, any PCB, you can get a bad impedance. But it is not always 100% that you will get a good impedance result without tuning. If you simply choose a smaller center contact, it still depends on what kind of PCB material you use and also the different thickness. Okay, this is for N-notch. Let's move to the THD connectors. The THD connectors is a little bit difficult, I think. First, you can check the gap dimension between the connector body and to the PCB. And with the simulation software and actual sample testing, you can know which kind of height or dimension that would be more ideal for you. And the second one is to check the connector center contact depth with the simulation software, also the actual sample testing. And the third one is trying to adjust the gap dimension where it contacts the center contact and also the PCB. Because THD connectors have an extra extended solder center contact, it is not so easy to get a smooth impedance result in general, especially when the application, its working frequency is quite high. You can see from our simulation result is that before tuning, of course, it's kind of not good, not ideal. But after tuning with these 3 points, you can get a better smooth one. But if you ask me what could be the frequency point that is not appropriate for THD connector, in general, I will give you let's say, if the application for you is above 6 gigahertz, then we would not really recommend you to use a THT connector, because when the working frequency is higher, the impedance caused by discontinuity will be more significant after all. Okay, let's move to the SMT connectors. SMT connectors is a little bit easier because it does not have the extend center contact. First, what you can do, of course, same as the THT, you can check the gap between the connector body and the PCB using the simulation software, or you can actually test with the samples. And then you can try to adjust the gap dimensions, which is this only two direction you can think about when you're using the SMT. SMT is easier to tune, much easier to tune compared to THT, as I said, because it does not really have the extend center contact. It's not to worry. Then with these 2 points, then you can get a better impedance result. Okay. Hopefully, it's not too difficult and too complicated for you until now. So for me, let's do a quick summary, a small summary for the presentation today. The first is the transmission line on PCB or in PCB. It's the straight line. It's easy for you to, for the designer to work on the layout. But for the turning right angle line, please try to give it an arc, a smooth turning shape. It will be helpful for you to make the good 50 ohm impedance. And for the designer of design when they're working on the connector design, try to create an inner notch and also try to adjust the ratio between the air and the inside insulation dimensions, or try to work on the outer contact inner dimensions to get you a good, well-matched right angle connector. For the last section, the last part is the connector types. For end notch, trying to switch on different type of center pin. If you are recording, try to match it well to your PCB, because your PCB could have different. There is a lot of different PCB thickness and different PCB materials. For the THT connectors, please be extra careful on the center contact length of connector, also the gap between the connector and the PCB. And for the SMT, the direction for you is please try to focus on the gap dimension between the center contact and the ground. Okay, this is the presentation here for today. In fact, we have an application note that is related to PCB transmission line design. This is done by my colleague Olin, and he is also the main material provider for this presentation here today. In fact, we have helped quite a lot of customers using our coax connectors. So if you do have issues or you have problems to get a good impedance matching, feel free to contact us or try to find someone that you know from Würth Elektronik. We will ask you about the information, then we can help you with the simulation to get you a better simulation or impedance result after all with our product, of course. Thank you for today, and thank you for your attention. See you.
All right. Thank you, Jason, for your interesting presentation. Before we move on to the questions, I will quickly share the handout with you. You should now be able to download it on the right side. And move on to the questions. The first question is, Would you recommend to route inner layer or bottom side and routing under the connector? Otherwise, the casing will also use an additional metal part close to the RF trace.
Hello, everyone. Yes. Okay, this is a interesting question here. Overall, in general, I will give you the answer is yes, because the metal will influence the trace line signals. And if you want more detail, you can send more information to me, and I will try to answer you in a more appropriate way with maybe more graphic and more what I can have here. All right. Thank you, Thomas.
Okay, perfect, Jason. We move on to the next question. Is it possible to customize a PCB connector?
Yes, as I have mentioned in the presentation, is that our connectors are already fine-tuned and well-tuned, and we do have some experience, actually not some, quite a lot of experience, customize a PCB connector for a customer. So we are willing to receive more requests from any one of you. That if you have a certain request, you can let us know the details on the PCB you're using and the connector type you want to use. So far, the series we have till today is the SMAs, RPSMA, MCX, MMCX, N-type, SMB, SMP. We have quite a lot of series. So let us know which specific or structure of PCB connector you want to customize, and let us know where you're going to use it, and we will try to make this work for you for customize. Okay.
Yeah, perfect. Thank you. Next question is for page 16. Is it always possible to cut off antenna part of the central pin on the opposite side?
If I get the question correct, the answer will be yes. But I think I will need to reply you later with more information with some graphic to demonstrate to show you better afterwards, after the session. Okay, thank you, Elda.
Okay, thank you. The next question is to slide 13. At what data rate frequency this becomes critical? What is measured in reality with TDR? If yes, what rise time was used?
Okay, the rise time, I remember the setting was 1 nanosecond, and we did not really adjust a lot of from the basic setting of the software. And the software that we use is actually HFSS. In reality, the TDR we will check, double check, compare. Sometimes we have the software, and also we measure the actual samples that we build, or we try to verify the product. And if you need more information from me about this section, welcome to write it to me to reach me to get more information or more detail. Okay, good. Thank you, Steph.
Okay. Next question is about page 15. How to solder the pin with hand when solder area is covered by the pin.
Okay. This will be a tricky one. How do I explain it now? It's usually we go through we solder it. Either you can cover the solder paste first and you heat the pin, or you try to go through normal SMT procedure. That's the two common method that we use from our side. But if you have anything you want to know, feel free to contact me. Okay, thank you.
Perfect. And do you provide simulation models of your connectors for 3D simulation, for example, CST Studio?
Okay, for this one is we do provide the simulation models, but we use HFSS, not the CST Studio, and we do give the 3D simulations. The experience that we have is actually some of the customers let us know specifically and in detail what PCB to use. Either it's a multi-layer or it's what thickness.
and the material that is applied inside the PCB, and also the part number that he is using our connector from Würth Elektronik. With these two basic information, my colleague Olen and also our team is able to support to check what could be the ideal transmission line design for you. And with this information, it normally helps the customer or the user step by step and get a good impedance tuning result. All right.
And we're moving on to the next questions. Are there CAD tools which can adjust these gaps for impedance matching at contact area automatically by calculating or simulation?
Okay. For this one, let me see. The CAD is matching by calculation or simulation. I will go for no, but for the reason, this is more related to the connector and also to the trace line you try to design in or try to apply. Yeah, I need to come back to this one later with more information on my side. Thank you.
Okay, perfect. Thank you, Jason. And we have a few more left. How to impedance for PCB trace antenna?
How to impedance for a PCB trace antenna? Ooh. I'm not sure what direction is this going, but please send me more information on this one. Oh, this is interesting. Okay, but yeah, I'm not sure how to answer this here. Sorry.
Okay, then we jump into the next questions. Why haven't tapers and DGS, detective ground structure, been used for compensation? And what is the impact of the solder tin for the different connectors?
Let me read through it again. The tapers and DSG reflective. Yeah, I have a lot of thinking going through my mind right now. Actually, so many pictures and a lot of information. But in general, it's oh, this is hard to. I think this one is also pretty. I'm sorry, this is also very difficult to answer right now live. But please send me this one. This is interesting, and there's a lot of information that we can provide afterwards. I'm sorry.
Okay, perfect. And what information would you need to support a connector transmission line simulation?
Oh, okay. For a connector transmission line, there is the material, of course, and also the structure, the length, and the overall designation you want, ideally. And then we can implement this information into the software and to give multiple times of simulation results and check what could be done. If it's a connector, after simulation, we build it out as an actual sample and we test it again through either go through the regular process, we go through the VNA, of course, double check. By going this back and forth, normally we will get a good, well-matched connector to make sure when the connector is handed to the user, it's already well impedance matched. Okay, thank you, Michael, for this question.
Perfect. I think we're done with the questions now. Thank you, Jason, for the time and for the questions. And also thank you very much for your attention. And we will, if there are any questions left we couldn't answer right now, we will answer them in the next days via email. And yeah, I hope to see you at the next session and wish you a good day. Goodbye.